Welcome. Let's begin with the decimal. Decimal is a floating point which provides precision in arithmetic calculation as we human calculate. Okay. So we also saw earlier that float value. Okay. Float also represent floating point values. So if we perform calculation of 0.1 plus 0.2 minus 0.3, as we human calculate, it should result into the 0.0. But if we execute in Python, it gives result something like this, which is close to 0 but not exactly 0. So for financial application, this error in performing arithmetic calculation cannot be tolerated. So the decimal data type is used for calculation with precision. Okay. So if we compare also the result object for the float value, it will give us a unexpected comparison also result. So 0.2 plus 0.1 minus 0.1 should result into the 0.2. If we compare it with 0.2 in float, it will return false, but we expect it to result into the true. Okay. So what exactly the result of this value? If we check it, it returns 0.2, and after this many 0, the error value occurred. Okay. So it is not exactly as 0.2 as we human calculate. Okay. This error occurs due to approximation. When we are providing float value in numeric value like 0.2, which is in decimal points, while converting it into the binary, it cannot convert exactly as it is. So it approximate the given numeric value in decimal to the binary. So while guessing their number, it results into the error. Okay. One solution to avoid it is use the round method. Round method rounds the result given number up to the given digit. Okay. So if we store the result which is 0.2 and up to certain number of 0, and after that 4, and if we want to round it to, first of all we print the result, and after rounding, if we use the round, we will give first argument is a number which is our result, and up to n digit we want to round it up to 5 digit. So if we print the result, as we can see, it is rounded up to 5 digit, so it becomes 0.2 as we human expects. Okay. So in order to avoid using round function every time, we will use decimal data type. So how to declare decimal? So before declaring decimal, we need to import the decimal class. So we will write from decimal import decimal. Okay. Now we can declare decimal variable. So for decimal, this is the constructor which takes two value. First one is a value, which is the value of a floating point number given in string. Okay. And next one is a context, which is used for customizing the parameters how the decimal operations behave. Okay. So we will see further in the tutorial. So first let's declare the floating point variable. So f1 equal to decimal, and inside we will provide the number in string. Okay, 0.2, and second variable which is 0.1, and if we perform operation same as above, f1 plus f2 minus f2, it should give us the result as 0.2 as we expect it. As we can see, it result into 0.2 exactly as we expected. Okay. So what happen if we don't provide the value, float value into the string, and if we provide the float object inside decimal constructor, we will lose the precision. If we declare the same value using float variable, the value becomes this. It will result in precision loss. Okay, so make sure that you always declare value inside string. Okay, now decimal have two special value. First one is a plus infinity and second one is minus infinity, which represent the same infinity in maths. Okay, so if we declare it using the special string infinity, plus infinity and minus infinity, it considered value as a infinity. Okay, for float there are three special values, same as decimal. First two are infinity inf, declared as inf, and second one is minus inf as for negative infinity. Okay, so these are the two special values, same as decimal. And next is not a number, nan, which is declared as nan. So nan is used when the result of operation on two object result is not a float object, which is represented using nan. Okay, so these are the three special value for float object. Okay, next topic is precision in decimal. So up to how many digits it perform calculation accurately. So in order to know it, we will declare two variable and perform a division operation. So if we check the result, as we can see, it performs up to 28 digit, as we can see in the screen. Okay, so by default the precision is set to 28 digit. Of course we can customize it using context as a second argument, as we saw in the decimal constructor. So how to set up the precision in decimal? Okay, so first of all we need to add getContext into our import parameters. So we will import the getContext parameter, which will bring the current context. Okay, so if we write getContext, which will bring the context, and we modify the parameter prec, which is a precision up to certain digit, it will set the precision for the decimal operation. Okay, so if we execute it, this, as we can see, before configuring the precision it performs up to 28 digit, and after configuring it to 6, precision equal to 6, it will perform up to only 6 digits. Okay, so that is the only one part of a context to customize the precision. Next topic, we will take a look at the context objects and its parameter, and each parameter having a possible values. Okay, so if we want to customize the context, we need to create a context variable. Okay, So in order to create a context variable, this is the constructor. Okay, so we will check its parameter one by one. First parameter is precision, PREC. It's the required number of digits of precision. So as we saw earlier, we passed as a 6, so it will perform the operation up to that number of digits only. Okay. Second one is a rounding. So while setting the precision, it has to round the value. So for rounding, we can provide any of this value, which is a rounding method, to round the given number. Okay. Next parameter is emin and emax. Is a minimum and maximum limit allowable for the exponents. Okay. So as per the CPU configuration of either 32-bit or the 64-bit, the machine has a limitation up to certain amount of value of exponent which it can calculate. So if we want to see that, we need to import those max emax, min emin, and if we print it, we can see that for 64-bit, for this machine is 64-bit, this is the maximum and minimum value for exponent. Okay. Next is capitals. If it is given value 1, it will print capital E for the exponent into the result of the decimal value. If we print a value of decimal data type, it will print E as a capital, and if we provide 0, it will print small e. Okay. Next is a clamp. If we provide 1, it strictly check the result decimal should fall between range this. Okay. It will not allow result to be outside of this range. Okay. And if it is set to 0, it will not strictly check. Okay. Next two parameters are flags and trap. So flags and trap are the fields which contain list of signals to be trapped, or we need to process it. Okay. So for generally new context, the trap field are used. Okay. So if you want to trap any signals, then we will use trap field, and flag field is leave as it is as blank. Okay. So what are the signals? So signal is a group of exceptional condition which occurred while performing operation. So as we know that while performing a decimal or floating point operation, it may result in error, such as when the number comes with division with 0, or infinity minus infinity operation, it will result in error. Or sometimes the number will go out of bound, so it will result in overflow. So for financial application or the critical scientific application, we need to catch those signals. Okay. And according to the errors, we can take certain action. Okay. So Python defines signals so that we can know that what exactly error is happening. So these are the signals which are allowed to be trapped, or we can catch them while performing floating point operation. So first one is a clamp. It is raised when exponent fall outside of emin and emax limit. Okay. So it will raise an exception when decimal value falls outside this range. division by 0. If non-infinite number is divided by 0, it will raise this error. Inexact. Inexact indicates that rounding has occurred and result is not exact. As we saw earlier with the float value, when performing operation, result was not as we expected. Okay, so this will raise that error while performing operation if the rounding is occurred and which is the result is not exactly represented. Okay, next is invalid operation. So operations such as infinity minus infinity, 0 into infinity, etc. are the invalid operation. So invalid signal will be raised. Overflow. When the number is stored which is greater than Emax value, then numeric overflow occurs. Rounded. When rounding occurred but there is no information loss, then this rounded signal is raised. Subnormal. It is exponent lower than E mean prior to rounding. Before rounding, E mean was lower. E was lower than the level of E mean. Underflow is the value is lesser than the minimum value which is allowed. It will result in rounded to 0. Okay. Last one is a float operation. So it raises exception when decimal and float values are mixed. As we saw earlier, if we declare decimal variable using float value, then it results into the precision loss. So in order to avoid this, signal must be trapped. Okay. So these are the signals which can be configured into the context object. Okay. But Python also gives us pre-configured context. So that are the built-in context. Okay. So first is basic context and second one is extended context. So they are pre-configured context. We will explore it by printing it. Okay. So let's first import it using from decimal. We will import basic context and extended context, and if we print those context, we can see the information. As we saw the context constructor and its parameter, now we can clearly see that what the basic context offer and what the extended context offer. So both of them are having precision to up to 9 digits. Rounding method is rounding half up for basic and rounding half even for extended context. E mean and E max are set to the maximum of platform, current platform. Okay. It will print, both are print with capital E in exponent. And if we can see here, traps, flags are null for both of the parameter, but if we see the traps, they are having signal like clamped, invalid operation, division by 0, overflow and underflow. So when these signals are generated while performing operation or floating point operation, it will raise error, and for other condition it will silently pass. So extended context is not trapping any signal, which means the error will pass. It will not raise any error while performing operation. Okay. So basic context is used when we are debugging an application. Okay. And this is used in production when the normally operations are carried out. Okay. In production only, where the result value are allowed in not a number or infinity instead of raising exception. Okay, so for the application, those application only which are allowing those special value. Okay, so for some scientific application or financial application might not allow it, so they have to use custom context as we saw earlier. So new context with custom requirement will be generated. Okay, so next topic is get and set method of context. Okay, now we have seen how to generate a context object, pre-configured context object. We forgot the last one, but which is a default context. So default context is a context object which is pre-configured. When we generate the context, when we execute the context constructor, this default context is written object. So this is a pre-configured object of Python which is returned when constructing new context object. So we can customize this default context so that when we construct any new context object, it will return this default context. So if we modify the parameter of precision to suppose 6, so when we are constructing new context object, it will be automatically having precision to 6 set. Okay, pre-configured. So we will see how to set context. Okay, so first method is getContext, which brings the current thread's context. Means for the current thread, this is the context. Okay, so if we execute it, we can see that current configuration for decimal context. Okay, now if we want to change with the extended context for some if our application allows those special values, we will use setContext method and we will pass context. In this case, we are passing pre-configured built-in context, extended context, and afterwards if we check context again, as we can see here, it is configured not to raise exception for the special values. Okay, it allows invalid operations which will result into the not a number or the infinity value. Okay, now if you want to configure current context to trap certain signal, so how we can configure it? Let's check out. So we will first get the current context for the current thread into variable ctx, and we will modify that variable. Okay, so we will add a trap signal which is floating point operation. Okay, float operation, and we will set it to true. So inside trap we will provide signal which we need to first import. Okay, so whichever signal we want to trap, we need to first import it. After importing, we will pass it inside the trap and set its value to true or false. True will add that trap in signal to the trap argument. So if we execute it and set it to true, and after setting it to true, if we print the context, as we can see, first as we set the extended context, trapping signal is none, and after adding it, it has added the float operation as a trap signal. So when we execute an operation which involves decimal and float numbers such as this, decimal and float comparison, it will raise an error. So if we execute it, it says that decimal dot float operation, okay, this is an invalid operation, okay, and if we set it to false, it will not raise the operation, not the error for the given operation. Next is a context manager for decimal object. So we will cover the context manager in upcoming tutorial also in details, but for now let's perform the context manager with statement. So with statement begins the context. So local context method is used to get the current context of the current thread, okay, as an variable, okay. So ctx. Now we can modify the current context, local context, inside the with, okay, block, okay, and after the with block, whatever changes we made into this variable will be resetted before as it was set earlier before the with statement, okay. So suppose with context we modify the precision to up to 12 digit. Now we have set it to, let's check the current precision. So current precision is set to 9 digit, okay, and if we perform a division operation, as we can see here, it is performing up to 9 digit, okay. So if we perform set the precision up to 12 digit and perform the same operation inside the with block, which is a context manager, it will modify that context. As we can see here, it performs up to 12 digits, okay. So and afterwards, without resetting the precision, it will reset again to 9 digit, okay. So if we execute all together, we can see before with statement it was 9 digit, and within the with block, which is a context manager as a local context, it became 12, and whatever operation we will perform within with block context manager, it will perform with that given change, and after finish it, as soon as this with block finishes, it restores, local context method restores the context which was earlier before this block, okay. So that is how we can customize the context using context manager. Decimal class also provide a some mathematical functions such as square root, exponential, log base e, and log 10 base logarithm. Okay, so these are the method. Okay, sqrt exp ln for base e and log 10 for log 10 logarithms. Okay, so if we execute it, as we can see, it performs mathematical function on the decimal object. Okay, that brings us to end of the decimal. Next topic is fraction. So same as decimal, if we want to accurately represent the fraction, we use fraction. So for that we need to import fraction class from fractions. Okay, and we declare it. We can declare it using multiple ways. Okay, so fraction class have multiple constructor. Let's see it one by one. First constructor is which takes two numeric value. First is numerator and second is denominator. So, okay, so if we declare it by 1, 2, it is 1 by 2, and if we execute it, okay, we haven't imported it, so we will select it and import it. So as we can see here, it will declare 1 by 2. Okay, second constructor is which takes float value. So float is converted into the equivalent of fraction. So if we pass it 0.5, it will convert it to 1 by 2. Next one is decimal. So we can also provide the decimal value, which will convert same as it is as the float value. And last one is string. We can also provide the same floating point value as string. So it will result in same fraction object. Okay, so on fraction object we can all perform all the operation as we saw earlier using int or float object. Okay, so these are the result of addition, subtraction, multiplication, etc. as we saw earlier. Okay, now coming to the attributes. So fraction objects have two attributes. First one is numerator and denominator. Numerator returns the numerator of fraction in the lowest terms, and same is denominator in the lowest term. So if we have a fraction object such as this, and if we check f1 after declaring variable f1, if we check numerator and denominator, it will print two values. Okay, next topic is methods. So if we want to restrict the denominator, we can restrict with the limit denominator method. Okay, so we will take the same example. Okay, so as we saw, it is printing a large number denominator. Okay, in order to preserve the same precision as we given. Okay, but we want to lower denominator and numerator, and we want less precision, so we can give this method argument as a lower denominator. Okay, so if we execute f1.limit denominator and we give a smaller value, it will limit further that denominators. Okay, so if we execute it, as we can see, it will, the denominator is lesser than 1000. Earlier it was larger. Okay, so that brings us to the end of the video.